Cancer. It is very likely that you know somebody that is diagnosed with cancer. Or even that you lost somebody, one of your friends or relatives, to this terrible disease. Now look to the person next to you. Is that a woman? Then the chance that she will be diagnosed with cancer is about 1/3. 1 in 3 women in the Netherlands will be diagnosed with cancer. Is it a man? Then the chance is even bigger. 1 in 2 men is diagnosed with cancer during his life in the Netherlands. It is a cruel lottery with too many losers. Me as a researcher at the VU Medical Center in Amsterdam, together with many colleagues, I hope to turn the odds by developing a new strategy for cancer treatment. So far, research dedicated on cancer treatment has resulted in 3 treatment options, and that are surgery, radiotherapy, and chemotherapy. And they are of great value. In some cases, they can effectively remove cancer cells, and they can even cure cancer patients. But they have one major disadvantage in common, and that is that they cannot discriminate between cancer cells and healthy cells. As a consequence, healthy cells are damaged and removed as well during the treatment. To avoid too much damage to these healthy cells, the cancer treatment should be applied very carefully, bringing in the risk that there are some cancer cells left behind that form a new threat. They can grow out and form a new tumor again after treatment. The key challenge in cancer treatment is to find a way to specifically kill every single cancer cell while avoiding too much cells to these healthy cells. And we might be able to do this with the patient's own immune system, because immune cells can specifically interact with cancer cells only. Did you actually thought about it? Why is your immune system not able to kill cancer cells like it will do with infectious diseases? The immune system is a host defense mechanism that protects your body from various types of dangerous threats. You can think of the immune system as policemen. These immune system policemen constantly patrol your body to look for bad guys, such as viruses. And when they encounter such a bad guy, they will kill it. So for instance, when you get the flu, you will feel sick initially, but after a week or so, you feel better again. And this is simply because the immune system policemen have tracked down and killed every single viral particle in your body. Now, what should it do with cancer cells? Cancer cells can, of course, be characterized as bad guys as well. Hence, the immune system policemen should respond to them as well. And this is indeed what's happening. Immune cells are able to effectively kill and remove cancer cells from your body. Why do so many people then suffer from cancer, while the immune system is able to effectively kill and remove cancer cells from your body? So what goes wrong? Cancer cells can evolve several mechanisms to make this immune attack ineffective. With this wall in place, they are protective for the immune attack and they will survive it. And when researchers realized this, they started to develop a new way of cancer treatment, and that is called cancer immunotherapy. Cancer immunotherapy aims to make the immune attack effective again, using the patient's own immune system. So there are several ways to approach it, and the focus so far has been on boosting the already existing immune attack. So bringing in more policemen and providing these policemen with heavier weapons to shoot. And it showed to be of great success. It resulted in decreased cancer growth, and it even cured cancer patients, which were not curable with the standard treatments. Therefore, cancer immunotherapy has been regarded as a new breakthrough in cancer treatment. But unfortunately, it was not always successful. And still many patients are not cured. So therefore we need to develop immunotherapy further. And one explanation why boosting the already existing immune attack was not successful could be that in these cases, these cancer cells had a much stronger immune protective wall compared to the cancer cells where the treatment did work. So in addition to boosting the immune attack, we may need to break down that immune protective wall at the same time, thereby making these cancer cells more vulnerable for the immune attack. But before we can do this, we need to understand the elements of this wall. We need to understand how these cancer cells are able to make an immune attack ineffective. Now, not only cancer cells, but also unborn children are protected from an immune attack. A fetus inherits half of the gene from the mother and half of his gene from his father. And it is the part of the father that is causing some problems, because the mother's immune system considers the contribution of the father as something that doesn't belong to her body, and therefore as a dangerous threat. So the mother's immune system is having an attack to her own unborn child. And this attack is serious, because without immune suppression, it is very likely that the unborn child will be rejected by the mother. But fortunately, the unborn child is capable to cope with this. It is able to make the mother's immune attack ineffective. And now the interesting part is that in this case we know the elements of the wall, because this unborn child creates a wall to make the immune attack ineffective, as similar with cancer cells. And these elements of the wall are glycan structures. Glycan structures are some kind of sugar molecules. These glycan structures protect an unborn child from the mother's immune attack. And research also learned from this example that glycan structures are capable of making an already existing immune attack ineffective. And now it turned out that cancer cells, the elements of the wall of cancer cells, have the exact same type of glycan structures. So if these glycan structures protect an unborn child from a mother's immune attack, they will also very likely to protect a cancer cell for the body's immune attack. Research just discovered the presence of these glycan structures on the cell surface of cancer cells. Now the next challenge is to scientifically prove that these glycan structures are indeed a mechanism of a cancer cell to evade immunity. I made it my mission to prove this. I dedicate my research to investigate the effect of cancer-specific glycan structures on the immune system. This is me in the lab, where I will put cancer cells together with immune cells. But in one condition, these cancer cells do have glycan structures. And in another condition, they don't have any of these glycan structures. By comparing the behavior of these immune cells between the two conditions, I hope to find out whether these glycan structures are indeed a mechanism for cancer cells to evade immune system. If this is indeed true, we might be able to block this interaction between glycan structures and immune cells with cancer immunotherapy, and thereby preventing that these immune cells will lose their ability to effectively kill cancer cells. Now look again to the person next to you. The chance that she or he will be diagnosed with cancer during her or his life is substantial. Would you get cancer because your cancer cells have these glycan structures which allow them to grow, because the glycan structure make the immune attack ineffective? If yes, we can help more cancer patients in the future by breaking down this immune protective wall within cancer immunotherapy. I truly believe we can bring cancer treatment to a next level. With cancer immunotherapy, we might be able to break down cancer defenses, making an immune attack effective again. And thereby, I hope to turn the odds of this cruel lottery. Thank you.